Welcome to the Health AI Brief, breaking down the AI shaping our world one concept at a time. When we think about an AI learning to read a chest X-ray or an ECG, how does it start? How does it know what a pneumothorax or atrial fibrillation even is? It can't learn in a vacuum, it needs a teacher. The most common way that we teach AI models in medicine is through a process called supervised learning. It is by far the workhorse of medical AI, and the concept's incredibly intuitive. So the analogy is simple. It's like training a medical student with a set of flashcards. On one side of the card you have a clinical case, an image, a set of observations, a lab result. On the other side you have a correct answer, the ground truth diagnosis. You show the student the case, they make a guess, then you show them the correct answer. The student learns by seeing this error between their guess and the right answer. Supervised learning works in exactly the same way. We feed the model a huge dataset where every single example has been meticulously labelled with the correct outcome by human experts. The model is supervised because for every prediction it makes during training, we provide the correct answer so it can measure its error and learn from its mistakes. Whether it's an algorithm learning to spot diabetic retinopathy from retinal photos, or one predicting sepsis from ICU data, the vast majority of AI tools that you encounter currently will have been built using this method. The process is relatively straightforward. Get a massive, high-quality, expertly labelled dataset. Use it to teach the model to map from the input, the clinical data, to the output, the correct label. Amassing the dataset isn't necessarily straightforward, but the techniques, once you have the data, are well established. Understanding supervised learning immediately focuses the attention on the most important and often weakest link in the entire AI development chain, and that's the data itself. It gives you two critical questions to ask whenever you see a study that's using supervised learning. First, who did the labeling? Were the chest X-rays labelled by a board-certified radiologists, or a panel of radiologists, or by a medical student? The quality of the supervisor or teacher directly determines the maximum possible quality of the model. The AI can never be better than the expert who labelled the data it learned from. Second, how good was the data itself? Was it a diverse dataset representing a wide range of patients, or was it from a single homogeneous group? If the model was only trained on flashcards from one hospital, it's unlikely to perform well when it encounters patients from a different demographic. The performance of the model is completely dependent on the quality and breadth of its training data. So that's supervised learning in a nutshell. It's a powerful and effective method, but the results are only ever as good as the labelled data used to teach it.